All right, so hello everyone, and welcome to our today's webinar with Antonis. So let me just make sure that everyone hears me. Okay, cool. Thank you, Yusuf. So hello everyone, we have already 30 participants with us today. That's amazing, and I'm pretty sure the number of participants will grow as we go through the webinar. Let me quickly introduce myself and what we do at SHA and the topic of today's webinar. So my name is Slim. I'm the education manager at Social Hackers Academy. Social Hackers Academy is a non-profit coding school. We started back in 2017 with the offline model, and then we switched to the online model, which is our actual model after the pandemic. And after doing that, we have been blessed with having students from all over the world. So at SHA, we are trying to democratize tech education, make it accessible to everyone, and we are providing scholarships to vulnerable group of people. We are teaching two main career tracks right now, but we are still diversifying our career tracks. So right now we are teaching front-end development and full-stack web development. We also focus on soft skills and durable skills during the journey, and we are helping out our students to get employed. And this is something I really want to share with you, with everyone, is that we have 88% of employability within 3 to 6 months after graduation. So everything is working good so far, and we are happy for that. And today we will be with Antonis Kalipetis. So hello and welcome again, Antonis. Antonis is a Docker captain and a software engineer at platform.sh. And today he will be introducing us to Dockers and containers. So we are really happy to have you with us again today, Antonis. Thank you for taking the time to join us and to introduce us to this amazing concept. And the stage is yours.
Hello, Slim, and hello, everyone. Thanks a lot for having me today. I'm really excited to be here and also see all the great things that you do have echo. Maybe
I think it's echo, yes, but I think it's okay.
Okay, because I'm on the earphones, so I don't know why. If it's very bad, maybe you need to mute Slim and maybe it's on your side. Okay, cool. So perfect. So let me share my screen, which is a very common thing that we do during the pandemic and all those days that hopefully will be past us in the future. So yeah, again, thanks a lot for having me today. I hope we have a nice discussion. The idea is that we'll talk about Docker and containers in general, and we'll see some more examples how we can leverage the powers of containers in our.
I'm sorry to interrupt you, but we cannot. It's not audible. So maybe if you try the computer mic, because earlier it was working fine. So maybe.
Is it any better?
Perfect. Yes.
Okay. Maybe I'll. I won't use Bluetooth audio because Bluetooth is very bad with Zoom.
Okay.
I'm not here to complain about Zoom, so I'm here to discuss more interesting stuff. So now that you can hear me, after all, so thanks a
you
lot for
very much,
having me.
Antonis.
And congratulations for all the nice work that you do with social hackers. I believe that it's really important, and it's really nice to see people standing behind it and supporting it. So let me share my screen again.
Okay, just one thing for our attendees. So do you prefer having the questions during the presentation or to keep the question after you finish?
While we do the presentation, feel free to ask them in the Q&A section or chat. Slim, if you can drop.
I will be monitoring, yeah.
Perfect. And of course, if you have questions at the end, we will also have time, but feel free to do them when you have them. And if it's something that we will discuss later on in the presentation, I'll just address it when time is due. Okay, so let's start. So a few words about me, although Slim already told many of them. So I'm a Docker captain, which means that I'm a part of the community advocacy program of Docker. You can imagine this similar to programs like Microsoft MVP. So this means that I like doing a lot of presentations, one of which is today and that you are part of. And we get early access to some features or other things on the Docker side. So that's really nice for us. Also, we get a lot of nice swag. But during the pandemic, swag was reduced. So we are just here with the presentations. I mostly code in Python, Go, and Node.js. So these are the languages I most work on the day-to-day. But of course, as I like to call it, languages are just tools. So if you have a question for another language, feel free to ask it, and I'll be happy to answer it. In my day-to-day job, I work as a software engineer in a company called Platform.sh, where we provide a web PaaS, a web platform as a service, so you can deploy your websites responsibly, because we care a lot about the environment and we make sure that all this runs in the most green and efficient way. And below that, you can see some of my side projects. We have a podcast, but it's in Greek, so sorry if you're not speaking Greek. It's called Mikri Kouveda. There's another tool called Volti, which helps you do end-to-end encrypted secrets, and Remote Work Cafe, which helps you find the closest cafe for you to work now that all us are working remotely. So now that we have all the introduction past us, let's start talking about the interesting stuff that we're going to talk about today, and this is containers. And before we answer what are containers and how we can use them in our day-to-day, I feel like the most important question that we need to ask is, why should I care about containers? Is containers a technology that I will face in my work, in my day-to-day job, or is something that I shouldn't really care about? So in order to answer that question, I'll start by telling a story. So in this story, we have two people. We have Bob and Alice. So Bob is a newcomer to a new company, so it's his first week, and he gets assigned a task. So Bob is very excited because he's ready to showcase his skills, and he will be ready to start contributing to the company. So Bob goes to the Git repository. Let's say it's GitHub. So he goes to GitHub and he clones the application in his local machine. And he wants to start the application so he can, see how it works and start developing this new feature that was assigned to him. He spends a whole day and he is not able to bootstrap the environment because there's a lot of configuration. There are different, artifacts that you need to build in order to start the application. So he surrenders after the first day, and he goes to his colleague Alice, which is a very seasoned developer, and tells her, Alice, I want help. I'm not able to do this thing. Help me because I'm at the dead end. So Alice is a very senior developer, so she has a very well set up local environment. So she goes and copies that environment to Bob. But when she does that, she sees that many of that tooling that she uses is very specific to her own machine. So she's not able to copy that environment to Bob easily. They spend 2 days together, in order to set up this environment to Bob's machine. And at the end of the day, Bob can go to the web browser and see the application running. So he's really excited. Now he's really, really ready to go and develop that feature, that new application. So he creates a branch, he develops the feature, he pushes the branch. And when he pushes the branch, he realizes that in order to implement this feature, he needed a newer version of Postgres, which is a very well-known database. So they were using the newest version in production, but the CI system, for some reason, was in the old version and thankfully was not crashing. But since Bob used the new feature from the new version of Postgres, the CI system was not able to run Bob's tests, and the tests were failing. So all that excitement of the first feature, again, goes to a nightmare, and Bob starts saying, okay, what I'm going to do now. So after he does that, he opens a ticket to the system administration team of the company and says, can you please upgrade also the CI system to the latest version of Postgres? Because we need that new version in order to develop that feature. The system integration, the system administration team is very fast. So within 3 days, Bob has the new version and the tests pass. So Bob is really excited. He hands over the feature branch to QA. QA says that everything's okay. And Bob, after like almost a week, is ready to deploy his first feature to production. So the day of the release comes, and Bob is really excited. He's talking to all his friends about the new feature that he's going to deploy to production for the first time in the company. And when the feature gets deployed, everything crashes. So Bob is really disappointed. Bob is ready to go to cry, because the issue was that the security team a few days ago implemented a patch for a CVE, for a very serious security incident. And that patch broke some of the internal system code that Bob's feature was using, and Bob's feature crashed the system. Of course, the CI system was not passed because it was not critical. So even though the tests were passing in the CI, the application was running in production. So the third try for Bob was very hard. So he takes back the code. The previous version gets deployed. Bob fixes the code to work with the latest Linux system that was deployed by the security team. And 2 weeks afterwards, he's got the feature in production. All this story is here to tell us that if we have different environments between our local environment, between our CI and our production environment, all those differences at some point will come and bite us. So we need to somehow organize all those environments, all the different environments that we are using, so that developers do not care about actual systems, but developers care about their day-to-day, care about developing features, and because developers, that's what they need to actually do and work. And containers, as we'll see hopefully in this presentation, is a technology that will help us and guide us through this process of canonicalizing and making all those environments as similar as they can be. So containers try to make all those environments similar, and on the development side, they create reusable development environments. And we'll see how we can have those developer environments and how we can describe them on our local machine. Then allow us to orchestrate our CI and CD environments, because most of the CI/CD environments that you might already use, like GitHub Actions, GitLab CI, Travis, Circle CI, or whatever you use, doesn't really matter. All those environments under the hood utilize containers in order to orchestrate and run your tests. So it's really important to make sure that your application is ready to run within those environments. And of course, there are many systems either directly containerized, like Kubernetes, Swarm, or other systems that we see in the end of it, or even systems that run as PaaS. For example, in Platform SH, run containers under the hood in order to deploy your applications. So your application, at the end of the day, it's very, very probable that it will end up running inside a container in your production environment. So what are those containers? What are those things that we are saying again and again? And you might see many blog posts out there saying, oh, you know, containers are the next big thing, or you should work with containers on your day-to-day. So containers are best explained if we compare them to virtual machines. So if we go back, we would remember that initially we had the physical servers. So if you wanted to deploy an application, you needed to have an actual server, an actual thing that you could go and you could plug it in to your Ethernet and to your power plug, and then this would boot up and would serve your application. Of course, luckily, we're not at these days anymore. Afterwards, what we did was to create very, very big servers, and we organized them in data centers, so in places that were meant to be co-located, all those servers. And then on top of those, we created virtual machines or VMs. So those virtual machines were like smaller machines that were completely virtualized, and our applications were running inside them. And then the next and the evolution of that are containers, which are even smaller things that run within those VMs. So if we need to compare containers and VMs, these are not two technologies that are competing against each other, but are technologies that are symbiotic, that work with each other again. So for example, if you are running inside a cloud provider like AWS, you will have your EC2 VMs, so your virtual machines running, and within those VMs, you will find a way to run containers because it will make it easier for you to manage those applications. So containers will coexist with virtual machines, and usually we have a number of VMs and a bigger number of containers. The main use case and differentiator between using virtual machines and containers is that you can think of virtual machines more like your vacation rental. So when you go to vacations, you want to have your own pool, for example, your own garden, your own terrace. So you want to have more like privacy. So you are willing to pay more money in order to have all this feature set available to you. So when you go to vacation, you try to have a more isolated, because you don't have any other people living with you, house, but at the same time, you pay a lot more money, because when you need to manage and handle all those things for yourself, then the cost is bigger. So there are use cases for virtual machines where we want our applications to run completely isolated and with specific kernel versions, for example, or other features. But we know that in those cases, we will pay more for that hosting. On the other side, containers are more like a flat building. So when you have a flat building, you have many apartments, and all the apartments have the same, for example, the same plumbing, have the same electricity. You don't have to pay for all those things for yourself, the same heating. So you have centralized installations for all the common things that you would like to use in that apartment, and all the apartments share some resources. So for example, if you want to turn on the heating, but the rest of the apartments do not, then you are doomed to be cold, or you are doomed to be hot. So you have to work well together with all the other tenants. And this is what containers are. Containers are applications containerized, living in their own environment inside a virtual machine that need to work well with each other. And if we manage to do this correctly, then we have a huge cost savings and a very easy maintenance effort needed to manage all those applications inside there. So if we would like to say in a few words, virtual machines are very nice if we need very specific isolation or feature set for specific applications, but containers are very lightweight, very fast at boot, and if we need applications that scale up, that scale out or in, so more containers running or less containers running at the same time, then it's easier to host our applications inside containers. So what are containers after all? So containers are not an actual feature. It's not if you go and search the kernel code for containers, you will not find a single reference to containers, because containers are a set of different features and tools inside the Linux kernel that allow us to jail, so to isolate and limit, so to make sure that we don't get more resources than the resources allocated to us inside. So you get a process, so a web application, let's say, and then you jail it and you constrain it inside a very specific environment. So those tools, you might have heard of them. They are called namespaces and C groups. So these are the tooling that we use in containers. And we use them to make sure that, for example, application A does not take all the available memory or all the available CPU inside the virtual machine, because this would mean that this would be a bad tenant, and that this tenant would make the life of the other tenants inside that virtual machine miserable. So containers are the policy makers, the patrol that makes sure that this thing does not happen. Of course, we are talking about containers, and containers are not a technology specific to Docker. Containers have existed long before Docker was introduced. Google, for example, has references of using containers for the last maybe 20 years. So the question is, why do we really care about Docker specifically when it comes to containers? And Docker is actually a company that introduced some very specific differentiators into using containers that make containers easy to use for normal people and not for hardcore system administrators. So before like 6 or 7 years before Docker, I wouldn't be able to run containers because I wasn't aware of all the tooling that needed to be in place in order to run them. But using Docker, we have a very nice user experience. So the experience is very nice. It has a very nice and easy to use CLI, and we'll see about it. We'll see it in a bit. It also created a packaging format, and we'll see how this packaging format is very important when we take our application from our local machine to CI and to production. Also on top of it, it added pluggable networking, storage, and other high-level concepts that are very crucial into running applications in production. So in order to make sure that all these flats are running in harmony together, we need to make sure that they all have the same plugs, they all have the same heating pipes, the same plumbing, the same everything. If you have a flat building and everyone needs a different voltage, for example, this will not work. So that standardization was what Docker introduced and helped us manage applications at scale very easily. Oops. So now we're going to go and play a bit, and I'm going to switch to my local terminal and see how Docker works and what are all those things that Docker does.
Antonis, I think we have a question in the Q&A.
Okay.
So Nick is asking if one can use this method only for web apps or also for mobile Android apps like APKs, Java Standard Edition FIG clients such as JavaFX.
That's a very nice question and a very interesting one. And when it comes to mobile developers, because I understand this is the main use case, then containers can help you in the following two ways. The first one is that you can package all the needed like tool set that you need to build your Android application, your APKs, and everything inside a Docker image. So let's say a standardized Docker container. So whoever wants to build that application can just run this container and have all the tooling available and not need to download all the tooling from the get-go each time. So that would be one use case. The other use case is that you can use those containers inside your CI system and build those APKs automatically. So let's say that every time you create a new pull request, or you create a new release, or you merge something to your main branch, then you have a CI job and automatically create a job that goes and uses that container that you have built with all the tooling available, and with that container builds the actual APK. So it might not be like night and day, which is the case with web applications, but of course there are many use cases for that. Also, I've seen some Docker images which boot emulators, so fake, in quotes, Android phones, and then using them run automated tests. But I have not great experience with that field, and I would not like to go anymore. So the other case is that you might use the Dockerized stack of the API team. So let's say that you work with an API team and you want to test a specific branch or a specific feature. So you can use the containers that were built for that specific feature from your API team, boot everything locally, and do your testing without relying on a staging environment or a specific environment for that feature set. So I think
that answers the question.
Sorry.
So Yannick said, thank you all. And also, Ioannis, anything that launches a GUI needs special. So, okay, so Ioannis is answering here. So we'll go to the question. I think we can carry on.
Yeah, when it comes to graphical user interface, things are not ideal because containers are mostly for system work, but you can easily utilize them. And if usually you want to introduce a technology if it solves one of your problems. So if all that packaging and automation is one of your problems that you have on your day-to-day, it makes sense to invest in a new technology and see if it works. If it doesn't, you can play with it, but maybe it's not the best idea to introduce it to your team and make their life a bit harder. So Docker works in what we call a client-server model. So the client runs on my local machine, and the server might be anywhere else. Of course, the server here is in my local machine too, but this does not mean I do not have other options. So with Docker, we can run any command we want. So if I do uname A, I'll see that I'm on a Darwin, which means I'm on a Mac. And this is the kernel, and this is everything that's running on my local machine. But if I do something like, let's use this one. So now I'm instructing Docker to run a new container that starts from something called Ubuntu. So this is called the Docker image, and we'll talk more about it in a bit. And we are going to run the bash command inside it. The others are arguments that are needed for the specific command, but nothing you should take very seriously. So if I do uname A here, so the same thing, you see now that I'm on a Linux thing. So I'm in a completely different environment, even though I'm on the same machine. The architecture is the same, so the architecture does not change. And this comes to the fact that containers cannot emulate everything. They're not virtual machines. So some things will stay the same even though we run them inside containers. But I'm running a Linux container. I'm running something called Linux Kit. And if I do etc OS release, I'll see that I'm running now inside Ubuntu, which is a very common distribution of Linux. So with very simple commands, without knowing anything about the Linux kernel, containers, namespaces, or C groups, I could run a command inside that container. And of course, if I do top, which is a command that shows all the other processes running inside here, I see that this container is completely isolated. So this container does not have any visibility of the rest of the system. So I'm within my flat, and I don't have access to the other flats. You wouldn't be happy if someone had the key to your apartment. And in the same way, you wouldn't be happy if one application could go and harm one of the other applications running inside that container. We can do, in the same sense, we can do this. So I'm going to do Alpine, SH, which is another distribution of Linux. When I don't have it locally, let's hope that my connection is good enough. Okay, it was fast. So now it went and downloaded one image. So it went to the internet and downloaded what I called Alpine, which is another Docker image. And now if I do cut this one to see the operating system release, I see I'm on a different distribution. So I can change a lot of the parameters, but I cannot change everything inside this container. So let's go back to the slides. So all in all, the important thing here to remember is that containers actually give more power to the developer. Containers are actually an interface, a way to communicate between the different teams. The system administration team, which is the team that handles your CI system, your production environment, and everything, and developers, because developers can, at the end of the day, create one artifact, the Docker image, and tell the systems people to run it. Because if you create a Docker image, you are sure that this Docker image will run in the same way in all environments that can run containers. So using this interface, this actual social interface, and not a code interface, we can communicate between those teams very easily. So in order to do all these things, and in order to have our local machines, our CI systems, and everything, we need some tooling. And of course, developers love tooling. And now we're going to go quickly through the tooling that is available to us when we talk about containers. So first of all, what we need to accomplish in this example is reusable developer environments. So we need to be able to run containers in the same way, both on my computer and on Slim's computer. So if Slim wants to create a new application, I don't want to spend like 1 or 2 days on his machine trying to set up everything. I want to have everything described in a specific format. And whenever Slim wants to start coding, he can just download the repository and be productive right away. We don't want to waste time into recreating all these developer environments, or pinging the senior developer and telling them, please could you copy your environment to me because I don't know how to code it. So in order to do that, we have what's called Docker Desktop and Docker Compose. So Docker Desktop is a desktop application provided by Docker that runs a virtual machine inside your computer. This is available for both Mac, Windows, and now Linux in beta, and allows you to run containers. So as we said previously, containers are not available into, there might be Windows. This is completely out of the question for now, at least, because it's not real containers. They're just like a thing that Microsoft has created on top of the existing tools. So Docker Desktop creates a virtual machine inside my computer. So you see, again, virtual machines and containers running side by side. And then inside that virtual machine, I can create containers easily using the CLI with the commands we saw just before. Then Docker Compose is a very simplistic CLI tool that allows us to describe the whole stack. So the application is not just the code that's running. Your application is the web application that's running. There might be a different front end. So you might have like a React front end being served from the React server. You might have an API which is written in Node.js or in Python or in Ruby. And then you might have some databases or caches. So you might have your MySQL database or your Postgres database and your Redis cache. So there are many different components that you need in order to run one single application. And Docker Compose is a single file and a CLI that describes all those components. And then with a simple command, you can bootstrap everything and run it locally on your own computer. And of course, all this tooling provides easy customization on top of it. Then we go on the CI and CD side. So when you go to your CI and CD system, you want a system that is able to run containers. And most, if not all, of the systems nowadays do that. And that makes sure that the same Docker image, the same thing that you have built and run locally on your own machine, will be the one that will be running on the CI system. And there you will be sure that the code that you have developed works in the same way in the CI system and your tests pass. So it's really important to have your descriptions there in the repository and make sure that this happens. Also, the CI systems through Docker and through containers can boot helper services. So for example, if you have databases, you can describe all those dependencies in code inside the CI system and say, I want to boot a Postgres container. So instead of Bob waiting for 3 days for the Postgres of the CI system to be upgraded by the systems team, Bob would go to the CI/CD file, change one parameter, and then this new version of the database will be deployed in order for Bob to run his tests inside the CI/CD system. Other examples might be a mock server API. So let's say that you are developing a front-end application. So you want to have a mock server API running so that your application can do the queries, get back the results, render everything, and then you have something like Selenium or another UI testing framework that goes and sees that the page is being rendered correctly. So all that orchestration, because at the end of the day, orchestration can be described inside your CI/CD files, and you do not need to depend on external services being up and running. So if I break the staging, for example, API, your application running on the CI/CD system for the front end will not crash because of it, because it will have its own mock server API running inside the container there. And the good stuff is all that is infrastructure agnostic. It can run the same way from my local machine to the CI/CD system and to everything. You don't have to ping other people and say, please upgrade the Python version or the system version or anything else. I know that my code will be run in the same way in all those examples. So the last, but definitely the not least, because it's the actual thing that gives value back to your customers and back to your company, is that you know that the exact same code that you run on your local machine and on your CI will be the one that will be deployed to your production environment. So this Docker image, this artifact that I built locally on my local machine, is the same thing that will be deployed to the actual production system. This means that the system engineers, the people that actually run your production system, do not need to go and know how your application runs. They just want to make sure that Docker and containers run in your infrastructure. So again, we come back to the interface, to the communication layer between two different teams. Developers build their applications using Docker, and then the systems team makes sure that containers, Docker containers, can run flawlessly inside your production cluster. You don't have to know anything about production, or at least not everything about production, and the systems team does not need to know everything about your application. All you need to know is that communication layer. Things like application dependencies. Let's say that you need a new version of a system library, or the security team, for example, needs to make sure that all containers running are secure. All those things can be described in policies and easily implemented through Docker files, which is the recipe that creates the Docker image, and make sure that the correct images run inside your production cluster. So at the end of the day, as we said, Docker made it easy for you and me to use containers. And this is the most important stuff and the most important thing that we need to keep in mind. So let's see how we are going to go to the cloud. So when we go to production, and this will be the last thing we'll be talking about production now, and we'll move back to our local machine. But when you want to move your code to your production, you have several options. First of all, we have things called container orchestrators. So we talked about the systems engineering team making sure in your production clusters, so in your production servers, that your applications are running at all times. Of course, they're not alone. They don't go to each container and make sure it runs. They have things called orchestrators, which is a software that makes sure that specific applications run at all times. They manage things like networking, they manage things like storage. So it makes it easy for them to manage a whole fleet of servers, many different servers, in a universal way. And this is really important because if containers and Docker did not impose all those rules, all those specs on how applications are built and run, then it wouldn't be possible to have all those centralized systems for us. If, for example, as we said, every different apartment had a different plug or a different pipe diameter, then it wouldn't be able for a centralized system managing the plumbing or the heating for the whole building. I think we have a question. So the question says that, can you describe some of the downsides and pitfalls around using Docker on macOS? The main downside and pitfall is that you run Docker in a virtualized environment. So things like data sharing between your virtual machine and your Docker container and your local machine are not like super fast as it is on Linux. But apart from that, Docker Desktop has done an amazing job in, minimizing those differences and making sure that those differences are easy to handle. So, of course, the downside is that you create a virtual machine and you run it, But the upside is that your application runs in the same way that it will run on your friends or your colleagues' computer, on your CI/CD system, and on your production environment. So I feel like this small downside of having a tiny bit slower storage or running a virtual machine is not enough in order to avoid this option. Not sure if this covers the question, but if you have any follow-ups, we will talk more about this in a bit when we will talk about local development with Docker. So talking about orchestrators, most, if not all of you, might have heard of Kubernetes, but it doesn't mean you need to run Kubernetes in order to run containers production. There are many other solutions that are easier and nicer to run when you go to production, and they involve Docker containers. So for example, if you use Amazon ECS, which is the managed container service by Amazon, you run containers, but you don't need to manage all this infrastructure. Same with Google Cloud Run, DigitalOcean App Platform, Azure Container Instances, and the list goes on. So there are many different platforms that run containers and make sure that containers run for you. So if you make sure your application can be packaged inside a Docker file, inside the Docker image, then this application can run flawlessly in all those systems, and that's really nice. Same thing goes for platform as a service environments like Platform as H, Heroku, or the list goes on and on and on. And we'll talk about the file system access on macOS in just a bit. So let's go back to reusable developer environments and see how we can leverage them and make them easier to handle, and how we can make file system access on macOS not terrible, and that's the goal of those examples. So we talked about that. Let's see Docker Desktop. So Docker Desktop is an application, as we said, and runs locally on your Mac or Windows, and soon on Linux because it's in beta. It packages Docker, Docker Compose, and other needed CLI tools. So everything you need in order to run Docker containers locally on your Mac or Windows computer is packaged inside Docker Desktop. You can easily mount local directories, and there are hacks and ways to make this faster. For example, if you were running an older version of Docker Desktop, this could be done using column cast. So this made sure that the file system was not in real time. I mean, it was replicated in real time, but it wasn't consistent in real time between your local machine and your container. And this resulted in huge speed increases between file sharing. This is not necessary anymore, because if you use VirtueFS, which we'll see in a bit, which is the new file system for Docker, it's even faster right now. So Jan, if you have big issues with file system access and speed on macOS, I suggest you try to enable that, and you'll see that you'll have a lot of improvements. Also, Docker Build Kit is another toolkit to make sure that images are built in a better way. So Build Kit is the new generation builder by Docker that helps you build images faster and with better tooling, like mounting SSH sockets and caching and other things, which are really, really nice. And of course, if you are on Windows, Docker runs on WSL2, which is the Windows subsystem for Linux. It's a very optimized local virtual machine that Windows runs locally on your computer, and it is really, really enjoyable to work with. To be honest, I was using WSL2 a lot for a period that I was using Windows. This was not enough to keep me on the Windows side of the equation, but at least made my life a lot better. And the cheat sheet is that you can easily query the local Docker, the local the local host of your machine through Docker using host.docker.internal. This is a very special host name that the Docker DNS resolves. Always use Docker Compose version 2, which is Docker space compose and not Docker hyphen compose. And of course, on Mac OS, you can enable VirtueFS. I'm pretty happy with it. Some people aren't. That's why it's still experimental, but I believe it helps a lot. Then going to Docker Compose, that's your go-to tool, in my opinion, for local development. You can describe everything in a single file, and using a single command, you can boot your whole infrastructure into it. You can override settings easily locally using Docker Compose override. And of course, you can have secrets and other dynamic configuration because you don't want to have secrets for local development inside your Docker Compose file in a file called .env, which will be read by Docker Compose and made available to your stack. A cheat sheet is that if you do use node modules, it's a nice idea to have a volume for those node modules inside your Docker Compose, because this means that you can have separate node modules on your local machine, which might be Mac or Windows, and different node modules inside your Linux machine, which is the Docker container. Always built with the CLI, which is using BuildKit under the hood, and it's really great. And of course, you can install dependencies both locally and inside the container to make sure that this is fun. So let's go and see a simple Node.js example. And before doing that, or while doing that, I'll answer also the question by Yannis saying that Unix sockets have several issues with permissions. So if you manage or need to mount a lot of Unix sockets inside Docker containers, then the new file system might not be the best option for you. But even the previous one was fast enough in most cases. Some applications running mostly things like PHP that need to run all the application on every request were the ones that were slower. Okay, so with Node.js, we have two important files that we need to use. So the first one is the Docker file, which is very simplistic for this one. So the Docker file, as we said, is the recipe, the steps that we need to follow in order to run our application. So this one is very simplistic, has a Node.js LTS. So it starts from a specific version of Node.js, and then it just adds one user, which is called VS Code, and that's all about it. So if our application needed to have different system dependencies, I would go to the recipe and say, okay, you need to run this command to create a directory, or run. So let's see what. And now we're also playing with Copilot, and it's fun. It's the AI system from GitHub that tells us what to do and autocomplete for us. Okay, so you see, using Copilot, you can be a developer now without any other issues. So this is a recipe that my application will be built from, so it's very simplistic. And then I have the Docker Compose file, which is the one that describes what happens inside my application. So here, it says that my application has just one service. I can have more than one service here. So for example, we have a database, and this will boot the database for me, or I could have a cache. I don't remember the latest version, so let's say Alpine. So in this way, whenever someone else wants to clone the same repository and start developing inside it, they will have those services available to them. What they need to do after cloning the repository is do Docker Compose up. And as you see, this will start pulling all the images needed for my application. And after doing that, it will kind of break. Okay, I need to add an environment. So I need to add a new password to the database, and I saw that from the logs here. in order to make sure that the database can boot. So I start again here. So as you can see, everything is running. And if I go to my local machine and go to localhost 3000, which is the port that this application is running, I can see that this application worked, and I can see that perfect hello world application. As you can see here, the application is very simplistic, so nothing really like fancy here. Another thing that we did was that we exposed another port. Port 9229 is the port that Node.js is using for local debugging. So even though my application is not running locally on my own machine and is running remotely, I can go here, and as you can see, I can use start :inspect, and this one will create a new inspect server, which is the debugging server for Node.js, and then run my script. So in that case, okay, I already do that. And I can go to my VS Code and say I want to attach bug. And I have already a configuration called attach to container. And I can easily attach to this container that's running and have a breakpoint. So if I do this again and go here, you will see that I get a breakpoint. I can have all the debugging features that I want from VS Code. So it's very easy to debug applications inside containers. You don't have to do extra work. You just need an application that exposes through a TCP port the debugging server, connect through VS Code or your favorite local development tool to that container, and see it running. So let's continue here. And as you see, the application continues running. Let's remove this because it's no longer needed. So in general, speed has been greatly improved. I know that some people, like possibly Yanis, are not very happy about the improvements, but I'm pretty sure that they are working on it a lot. And I mean, nothing personal, but they are really working on it. And it might not be optimal today, but as day passes, speed becomes even better and even better. And to my personal opinion, all the upside that you get from running your application in a containerized fashion and having things like Docker Compose running all your services outpaces all the downsides of sometimes slow file system or some bugs or sometimes a bit more clunky way of handling things. At the end of the day, it's really important to know why you are introducing a new technology inside your stack, be it your local environment, your CI, or your production. If you go and see that the downsides are more than the upsides, then maybe that's not a nice introduction. And containers are not always the answer to all your problems. Containers will introduce new problems to your day-to-day, but hopefully these new problems will be smaller than the problems that they actually solve. If they don't solve any problem, then you don't have to introduce containers. It's not like you need to introduce them because they are cool or because they are the new way to go. So a few things about the future, and this might be a solution for problems like the ones that were mentioned about the speed, is that you can actually run all your development environment inside the container. So you can have the container having the code locally, and then run your Visual Studio Code server inside the container. And that means that everything is locally accessed inside the container. And since VS Code is a client-server model again, you can run your UI for VS Code on your local machine and the server for the VS Code inside the container. And this has full access to the dependencies, to auto-completion, to everything inside the container. And in those cases, file system speed will not be an issue because there will not be any mounting of file systems. Everything will be inside a Docker volume. And of course, let's see what we'll get from such an option. And I think we have a few more minutes. Slim, do we have?
Yes, we do. We do. Don't take your time. I mean.
Awesome. I wasn't sure if it was 1 hour including or not including questions. That was Anyway, so the bleeding edge stuff is that you can run everything inside there. You have your Docker remotes, you have all your developer environment ready to go. You just click a button and this spins up a Visual Studio Code UI and everything. You have your supporting services using Docker Compose file. You have autocomplete, you have, anyway, we'll see it here because if we don't see it, it's not fun. So what I did here was I have a folder called dev container, and this has a JSON file that describes all my configuration. This is very simplistic, but I could add more things here as I see fit. So this has a name, okay. This has the compose files that I'm going to use in here. So the compose files has, as you see, this is using cast in order to have a better file system performance. This is not needed in my local installation because I'm using REUSABLE, which is a new file system from Docker. But if you have a previous version, this will not work. Also, I'm using, you can have a mount for the local Docker socket, so you can do Docker PS and those things. If you want to use ptrace or specific security options or anything else. So this file describes how the developer environment as a whole will be bootstrapped. And this describes the high level of things that we're going to use. So if I do that, and first of all, let's shut down this one. Perfect. So here I can describe all the extensions I'm using. Let's see, what extensions does GitHub Copilot believe I need? I don't need this one, I need something with Node. Node.js debug. Okay, let's do this. So what I'm going to do is reload inside container, reopen container. So I'm instructing Visual Studio Code instead of using the client-server model on my local machine to run the server model inside the container. So this is going to restart, and it's going to rebuild my environment, as you see here, and it's going to start my application on the local machine, on the container, including the Visual Studio Code server. So now when I open a terminal, I'm inside the container. So all my environment is running here. As you see, I'm inside Linux because I'm inside the container, and all the Visual Studio Code is running in here. So if I go to index, another breakpoint, and do node index.js, as you see, this starts the port and listens to port 3000. And if I go here, hopefully this will work. Okay, it works. And in order to make it more believable, we will change something, rerun the server, and we'll see that, okay, this works as expected. And if I do, if I go to nodes.json, and I create a new profile, so let's call it type node request. Let's hope that I remember all the commands here. I think args. Name local. And I do select and start debugging. I select local. I think it worked. No, it didn't work. Okay. Arguments. Let's do one more try. Console. Oh, nice. So my application is running here. And as you see now, without exposing the inspect server or anything else, we can easily see that we get all the debugging information here. Again, I can see the request. or anything I need in order to do debugging. So there's another question, but let's quickly go to the next slide because I think it's the last one, which is called questions. So
I think we don't have any question in the chat nor the Q&A, and I think I know why. Because the majority of the attendees today are from our classes, and they are from class 18 that started, this is their third week. So
okay.
Now their brains are like smashed potatoes. So that's why. So if someone has any question, like just shoot, guys.
Yeah, I mean, feel free to ask any more, let's say, introductory questions. It's fine to not know everything. I mean, I've been using Docker for maybe 5 or 6 years now, so sometimes it's not easy to remember how it is to be a newbie, but newbies are the most important people, so I'm happy to answer any question.
Okay, so they were nodding, let's say in the chat, but what I said, and Yusuf is leaving. Ioannis, the VS Code feature is just about the coolest I've seen.
Yeah, it's really nice, and the good thing about what I showcased about the integration between Docker Desktop and VS Code is that the development is being done in both sides. So both Docker Desktop tries to present features for VS Code and VS Code to have features that work nicely with Docker Desktop. So this makes a very nice thing because both companies, they're not like, VS Code is the best and we will do everything, or Docker Desktop is the best and we'll do everything. VS Code is a very nice tool for local development. Docker Desktop is an amazing tool for local development, and then they can coexist. So the end result is really interesting and really nice. So you can either go to Docker Desktop and open a container inside VS Code, or go to VS Code and run a developer environment inside Docker Desktop. It's both ways. Nice.
So I think we don't have that much of questions. It was a really nice presentation and very detailed, and thank you for the time you took to prepare it, and thank you for being with us today, Antonis. It's really a pleasure to have you with us.
It was my pleasure too, and if anyone wants to reach out, this is my Twitter account, or in LinkedIn or whenever. Also, I'll make sure that you have the presentation, so you can send it to the list that attended or anyone else afterwards.
Okay, cool. So actually, since the webinar was recorded, it will be on our YouTube channel tomorrow, so you can watch it again there, and we will add in the description your LinkedIn account and maybe the slides. So awesome. Cool. All right, so thank you everyone for attending this amazing webinar with Antonis, and I think it's time to say have a good evening, good night to everyone, and see you around.
Bye-bye, wherever you are in the world. Have a nice evening, day, or whatever you have now. Bye-bye.
Bye-bye, thank you.